Hi, this is Gilles, the radio prepper. This video is for beginners. I get a lot of questions about frequency, modes, bandwidth, and bands. And those terms might be a little confusing to people who are starting radio, so it might be also a good review for people who already know. But we'll start with something that we all know already, and that is the FM broadcast radio band, 88 to 108 megahertz. So what is a radio band? Well, let's take the FM broadcast band. It starts at 88 megahertz and goes up to about 108 megahertz. What does that mean? 88 megahertz refers to the frequency of the electrical current that's used to send radio waves. So if we have here 0 volts, meaning no electricity at all, we have AC current, alternate current, which goes up in voltage. Voltage is the force of the electricity. Goes back down, crosses the 0 point, and goes back up here. And it keeps on going like this. And this is a bit like your house current. Your house current, for instance, in the US is 110 volts. And it does this either 50 or 60 times per second. So it's 50 or 60 hertz, meaning that it switches polarity 50 or 60 times per second, depending if you live in the US or in Europe. In Europe, the force of the current is 220 volts. The frequency then is how many times this occurs in 1 second. In the case of 88 megahertz, it's 88 million times per second. So 88 megahertz is equals to 88 million hertz. And that's a lot of switching in 1 second. You do need to know what these units mean. So hertz is simply how many times per second the current switches polarity. We use hertz, we also use kilohertz, thousands of hertz, or megahertz, millions of hertz. And you will be using these units in everything we do. So know what megahertz, kilohertz, and hertz mean. When talking about frequencies, we will usually use either megahertz or kilohertz. Hertz are used for bandwidth, and I'll get to that later. When we talk about a band, however, the band is a range of frequencies. So if we take FM broadcast radio, we talk about a band that goes from 88 megahertz to 108 megahertz. But usually we refer to that band, that range of frequencies, as a wavelength. The wavelength is the length in meters between this crest and this other crest here. So here is your wavelength. And the wavelength is dependent on the speed of light. If we take the FM band again and we take, let's say, a middle frequency about 100 megahertz. If we want to know the wavelength, we take 300 divided by 100 and we get 3 meters. So the FM band could be called the 3-meter band. But of course, for FM broadcast radio, we just refer to it by the name FM band, and that's it. But in amateur radio and other radio services, we use the wavelength. So, for instance, if we take 3.5 megahertz, we get about 85 meters. But because this band goes up to 4 megahertz in the US, we call it the 80-meter band. And that's how we refer to bands, basically. We'll get back to the commonly used bands for radio, but we'll talk about the mode. The mode here is FM, frequency modulation. What does that mean? Well, To carry someone's voice, you need to modulate the signal so that it can be demodulated on the other end at the receiver. So we modulate the frequency, meaning that this frequency here is going to be changed a bit, fluctuating to the sound of your voice. And that will allow the signal, your voice, to be carried over from a transmitter to a receiver. If I want to draw what FM looks like, it's basically a signal that will switch frequency depending on your voice. Now the power of the signal remains the same. This is the frequency changing on the tone of your voice. There is another mode that you probably know as well. It's AM, amplitude modulation. And in this case, it's the power of the signals that will fluctuate. And not a very good drawer. And carry your voice. So the power changes. And here's your signal here. Here's a better representation of AM with my poor drawing skills. So we have your voice here modulated by the power of the radio. And that's what's going to be demodulated on the other hand. Both FM and AM are not very efficient because they take a lot of power to carry the signal, a lot of bandwidth, and I'll get back to that. They're not very efficient, however, they're very good for audio quality, and that's why both of them are used to send, of course, to broadcast music. Little radios like this handheld, for instance, use FM frequency modulation because it's used for shorter distances and good audio quality, but it's not very good at long distance communications. It's possible, but it's just not the best. Another mode has been invented, actually two modes I would say, and I'll add some more, but basically we are going to take the AM signal here and we'll get rid of the carrier frequency here, the center frequency of the signal, and we'll remove one of these sidebands. This is called a sideband. So let's say we remove the bottom one. We'll be left with the upper sideband, USB. The lower one is called LSB, lower sideband. Both of these are SSB mode, single sideband. The advantage of this is that the whole of your power, much more power, goes into one sideband, so the signal is going to go much further because it just gets more power. Now the audio quality, of course, takes a beating, and when you listen to USB or LSB, it sounds a bit like Donald Duck, but it will go much further than AM or FM. Now imagine that we're looking at this sideways. So let's say I put the sheet of paper like this and we looked at the signal on a certain frequency range. So let's say we have, we'll take the 2 meter band, 144 megahertz to 148 megahertz. And we look at an FM or an AM signal. These signals will be fairly wide. So you'll see a peak like this, and that carries your voice. When I say fairly wide, well, in FM it might be something like 12.5 kilohertz. And that's a lot of bandwidth, and that's what bandwidth means. It's the width of the signal. If you use a certain amount of power, let's say 10 watts, the 10 watts will be spread over this bandwidth here. So all your 10 watts will need to be used to fill this bandwidth, this signal here. So again, it's not the most efficient. However, if you take a single sideband, upper or lower sideband, your signal will be much narrower and it will look something like this. And you can see this is about 3 kilohertz. So if you use the same 10 watts in this signal, actually it will go a little higher, but it won't be any wider. So you get more range using a mode that is more narrow in bandwidth. And that's why on certain ranges of frequencies we use USB or LSB for long distance communications. Now let's take another case, another mode, Morse code. Well, Morse code is not a mode, it's a code, but Morse code uses CW mode, continuous wave, and it's just a tone. It's usually a 600 hertz tone, which is about 30 hertz wide. So this is very, very narrow, 30 hertz. And of course you can see here, if we put our 10 watts into a CW signal, it will go much higher than an AM or FM or single sideband signal. So it will go even further. There are digital modes that use even less bandwidth, and some of them use more, but digital is another all other animal, because of course some digital modes are wider but much more efficient at decoding very weak signals. But CW, Morse code, is very good at long distance communications, and the advantage of it, of course, is that radios are very simple. And by the way, you can't say I'm learning CW. You can't learn CW the same way you can't learn to speak FM. You have to say I'm learning Morse code, and you're sending Morse code using CW. Our frequency ranges as used by amateur radio, CB, handheld radio, walkie-talkies, etc. are divided into basically 4 types, 4 ranges of frequencies. We have HF, very widely used, high frequency, and that's about 3 to 30 megahertz. Below that we have MF, medium frequency, and I don't remember the bottom of it, but it's below basically 3 megahertz. So AM broadcast radio, for instance, is MF, medium frequency. Also, there is an amateur band in there that's 160 meters, and that's 1.8 to about 2 megahertz, if I remember well. I haven't really experimented with this yet, but it's good for certain things, like it has a good ground wave, so good for local communication to quite a bit of distance. HF. Then we have VHF, very high frequency, which is about 30 to 300 megahertz. And then we have UHF, which is above 300 megahertz, and I don't remember exactly where it stops, but we're not really concerned with that. For instance, the 70 centimeter band is in UHF, and that's 432 megahertz to, I don't remember exactly, but I think it's 440, depending on the country, of course. VHF bands that are well known in that range are the 2 meter band. We have the 4 meter band for some countries like England, and we have the 6 meter band. Some frequencies, some bands below medium frequency are used by amateur radio operators, but very few. And some people operate above UHF, but again, very few people. And all these modes, all these bands are fairly experimental. But we are going to use essentially, mostly one of these 3 ranges of frequencies, either HF, VHF, or UHF. HF is used for very long distance communications, and VHF and UHF are used for more local communication, although the bottom of VHF can sometimes go pretty far. In the HF range of frequencies, we are mostly going to use SSB modes, so either USB or LSB, and sometimes AM. On the VHF and UHF bands, we are mostly going to see FM for walkie-talkies essentially, and sometimes SSB as well. And a few people still use AM also, and with some old radios. And you can use any modes on any frequency, but some frequencies are better or mostly used with certain modes because of the range that they cover. VHF and UHF are mostly line of sight, meaning that they are used for direct communication in a straight line. You're not going to rely to some exotic propagation modes, although they do happen, especially in VHF, but mostly it is for local communications between two stations that are in direct view of each other. For HF communication, the high frequency 3 to 30 megahertz, and by the way, CB is included in that because CB is 27 megahertz. It's a little bit more interesting, I would say. Let's picture the Earth's surface here. Now the problem is, if I'm here, and the guy I want to talk to, the station, is actually here, the problem is that I have the curvature of the Earth here that is an obstacle, and my radio waves cannot go through. So, of course, this is not to scale. Or there could be, say, a mountain here, or a hill or something. I can communicate with the other station. But the ionosphere here, which is about 400 kilometers above the Earth's surface, can refract HF signals. Meaning that if I send a signal here, it can be refracted in the ionosphere and come back down to this other guy here. And that's very, very desirable because it allows us to make very long distance communication between two stations. Now, depending on the frequency, if you take upper HF, like CB for instance, CB has a problem because if the angle is too high, your signal can just go straight through the ionosphere and out to space, and that doesn't help anyone. Usually frequencies on the upper HF, like CB or even the 20 meter band, 14 megahertz, will need to be used during the day, because during the day the ionosphere here is powered by the sun and is much stronger and will refract radio waves much better. But some bands, like the 80 meter band, if you use a horizontal antenna, can actually refract at a very high angle and be used for regional communications over shorter distances. And when I say shorter, I mean a few hundred miles. Upper HF is better for very, very long distance, but during the day. 80 meter, for instance, will work better at night, but it does also work during the day. 80 meter is like a regional telephone, and I'll get back to that. So now you have a better idea of what a modulation mode is, the frequency in relation to the wavelength, and you know that we have frequency bands and that they fall into larger ranges like HF, VHF, UHF. And now I'll quickly mention a few of the most common amateur radio bands and non-amateur radio bands. And we'll start at the bottom of the range, regarding frequencies. So the 80 meter band is one of the lowest, most commonly used by amateur radio operators. It's 3.5 megahertz to 3.8 megahertz in Europe and 4 megahertz in Europe. So again, the 80 meter band is one of the most important bands for amateur radio and prepping. Why? Simply because, again, it refracts at a very high angle on the ionosphere. So it's very good for regional communications. Ranges, from maybe a couple hundred miles, 300 kilometers to maybe, 1,000 miles. And those are the most important ranges. One tank of gas, it doesn't take much time for someone to cover that distance. So if you can communicate with a group of people that you map around you on a regional range, that can really be very useful and, save your bacon. Then we move up to another band that is very important for prepping, and that is the 40 meter band. Why is it very important? Because it can do everything. It can do regional communications, high angle of refraction, and that's called NVIS, Near Vertical Incidence Skywave. You use a horizontal antenna, so the signal is always beamed perpendicular to the wire. So you're going to string your antenna horizontally, the signal will go straight up and rain back down, covering a regional range. So 40 meters is very good at that. But it's also good at very long distance communications too, if you string your antenna vertically. And of course the antenna is a half wave long. Well, the best antenna, in my opinion, is a half wave long. So a 40 meter band antenna is going to be roughly 20 meters long, 64, 65 feet. And that's fairly long, and it's probably the upper range of what you can throw in a tree, a wire up a tree. Longer than that, you're going to have trouble. So 40 meters, if I had only one radio for prepping, I would choose the 40 meter band because it can do both NVIS, high angle, regional range, and vertical antenna, long distance skip for very long distance communications. The 40 meter band is 7 megahertz to 7.2 megahertz in Europe and 7 to 7.3 megahertz in the US. So now we go up to the 30 meter band, 10 megahertz, actually 10.1 to 10.15 megahertz, mostly reserved for digital modes and Morse code. Well, actually Morse code is sort of a digital mode, but the computer is your head. So in most countries, voice modes are not allowed on the 30 meter band. And it's a very good band because in some circumstances it can do NVIS, but I wouldn't rely on it. The upper limit for NVIS, high angle regional communication, is about 10 megahertz. So the 30 meter band is just at the very top of that. But it's a very good band for long distance communications, and sometimes when higher frequencies don't quite make it, 30 meters will work. I'll also mention the mode used on 80 meters and 40 meters. By convention, 80 meter, the most used mode on 80 meters is LSB, lower sideband. Same for 40 meters, lower sideband. Although a lot of military radios only have USB, upper sideband. So you just use upper sideband, but you'll find much less people listening to upper sideband on 80 and 40 meters that you will find people listening to lower sideband. And of course, a lot of people listen to CW, listen for Morse code on CW mode. Then we get to a very widely known and used band for amateur radio again. It's the 20 meter band. 14 megahertz to 14.35 megahertz. And 20 meters is very widely used because it's a very good band for long distance communications. And the band is open, or propagation actually works most of the time, except in the middle of the night. Usually, although it does happen, but 20 meters is good for DX, intercontinental communications. And it's fairly reliable. Now, when we get to bands that are above the 20 meter band, so above 14 megahertz, so you have the 17 meter band, 15 meter band, 12 meter band, CB, and the 10 meter band, we get anywhere from 14 to 30 megahertz. It's much less reliable. It does provide the possibility of making very long distance contacts, but it's not going to work all the time. So you can't really count on it. And that's why for prepping, those are not really good choices. I would personally stop at 20 meters, 14 to 14.35, and leave it at that. The other bands, upper HF, are a lot of fun to play with, but again, reliability is not the best. So now we'll move to VHF. VHF is anywhere from 30 megahertz to 300 megahertz, and that's a very wide range of frequencies. The FM broadcast radio band is in that. Of course, you can't communicate on that. It's for music, and radio transmission. But if we take, for instance, 30 to 88 megahertz, bottom of FM, a lot of frequencies that are used by the military, actually, and a lot of older radios that you can buy are military radios, and they use FM, the frequency modulation mode. We also have bands like the 6 meter band, which is 50 to 52 megahertz in Europe and 50 to 54 megahertz in the US. And people do use sometimes SSB modes on that band, a single sideband, because sometimes the 6 meter band will behave like HF, but not very often. And when there is an opening, when the communications is possible, everybody jumps on it, and it's a big mess. So you really don't rely on the 6 meter band for very long distance communication. It can happen even in FM, but again, it's mostly for local communications. Then we have the 4 meter band for England and some other countries, 70 megahertz, around 70 megahertz, again for local communications. If we go up again, we go to the 2 meter band, 144 to 146 megahertz in Europe and 144 to 148 megahertz in the US. And again, some people at the bottom of that band will use SSB and even CW, because sometimes you have some weird modulation modes like tropospheric ducting and all that stuff that will allow long distance communications, but you really have to keep an eye on it for those openings, because it's not going to work most of the time. You have modulation, not propagation mode, I should say, like meteor scatter, and some people even bounce signals on the moon, and amazing stuff. But for prepping, it's not something you want to rely on again. Then we'll go up again to UHF, ultra high frequency, and that's the 70 centimeter band, 432 to 440 megahertz. And that's those radios here, handhelds. Actually, this one is VHF and UHF, so it has the 2 meter band and the 70 centimeter band. So you have two bands here. In FM modulation mode, it also has a digital mode, DMR. That's something entirely different, but it's very efficient. Well, it's fairly good for local communications. It doesn't have any Morse code or anything like that, no SSB, so you can't really count on it for very long distances, although sometimes it will go up to 100 miles. You never know, and with a good directional antenna, you can even get a little bit more than that. And sometimes, again, there is an opening and boom, you go 1,000 miles, but it's fairly rare. So UHF is used for local communications. Now we all have our favorite bands, of course, and favorite modes. My favorite modes, for those who watch my videos, know that it's the CW mode, to send Morse code. Why? Because it's really efficient and it doesn't require, a computer like a digital mode. And it's probably the most efficient mode that doesn't require a computer. So the radios are very simple, they're very small, and they use very little current, and that's why I'm a big fan of Morse code and CW mode. I'm a big fan of the 80 meter band, the original telephone. The antennas are very long, 134 foot, but if you string them horizontally, it's not so much of a pain, and you can get very reliable regional communications that way, using modes like USB, LSB, and CW, even digital modes. I also like the 40 meter band for the same reasons. I like the 30-meter band because it's, it's pretty much Morse code only and digital modes only. So you find a lot of traffic in those modes on that band. Then I like the 20-meter band because everybody uses it. And it's very good for very long distance communications. Used by sailors, for instance, on 14.3 megahertz for the maritime nets. On VHF, I really like the 6-meter band on FM, simply because I have military radios that are on 6-meter FM. So it's very good for communications in wooden areas, and it works extremely well. We have the 2-meter band, which I really like for SSB contacts to extend the range of local communications with a directional antenna. UHF I used for local communications with the walkie-talkies, and I like it because it requires pretty short antennas and they are still efficient. So you see, there are lots of reasons why to use certain frequencies and certain modes at certain times for certain reasons. And that's why really you should get into amateur radio and learn how to take better advantage of those different frequencies and modes of communication. You could, of course, stick with CB and those little FRS or GMRS radio, PMR radios for handhelds, but you're going to be missing out a lot on the HF bands. Well, CB is the upper HF, but you can't really make reliable very long distance communications with a CB. It's really good. I like CB. I started with CB, but I know its limitations and it's not something I will count on. Of course, I would suggest anyone to get one because a lot of people have them somewhere in a drawer, and if the SHTF happens, all those CBs are going to be coming back out, and you probably would have some people on those frequencies. So definitely have a CB or have a radio that can listen to those CB frequencies and even transmit, although of course it's not allowed. So only a CB radio can be used to transmit on CB frequencies. If you still don't want to get an amateur radio license, at least have a receiver that allows you to listen to the HF bands. And that's very important because you can gather a lot of information that way that comes from further away, or even, from bands like the 80-meter band, when you're probably going to have a lot of chatter on a regional basis. So that's very important for you to know. So I highly suggest that you get an amateur radio license. It's not that difficult really, and believe me, don't worry about being on the list. You're already on a bunch of lists, so it's not something I would worry about. There really aren't any good reasons not to get an amateur radio license because it gives you access to so much bandwidth, so many frequencies that you could transmit on. Well, I think I covered most of it. I hope I didn't forget anything. I might have. I will, of course, answer all the questions you might have in the comments below, but I would prefer that you went to patreon.com, signed up and asked your questions there, because that really does help. Thank you for your time. Have a good one.